Hello and welcome to Module 6 for ED 584. This module serves as a review and expansion upon our study of t-test statistical analysis methods. In previous modules, we have examined t-test methods that are used to test hypotheses addressing group differences associated with a measured variable that is continuous data. The one independent sample t-test, sometimes also referred to as the one sample t-test, allowed us to determine whether the population mean of interest, is equal to a hypothesized value, the test mean. Like all statistical procedures, there are certain assumptions that should be met to obtain valid information. For the one sample t-test, these assumptions are that the data in the population being sampled is normally distributed, that the selection of the sampled data occurs in a random fashion, and that the probability of each measured outcome is independent. Random sampling usually ensures that the assumption of independence has been satisfied. The term robustness is sometimes used to describe the extent to which a statistical method provides valid results even when the statistical assumptions of the test are not perfectly met. The point at which the results are valid versus invalid is not always clear and may require the researcher to make informed decisions as to whether or not the analysis procedure in question is appropriate for the situation. It is worth noting that the one independent sample t-test method is fairly robust to violations of the normality assumption when sample sizes are equal to or greater than 30. Robust meaning that the method procedures valid results even when the assumption is not very well met. We have also examined the related samples t-test, and this is sometimes referred to as dependent samples. This test allows us to test hypotheses related to differences between two populations in which a participant in one population sample is related to a participant in the other sample. They may or may not be the same participant. Repeated measures or matched pairs design. Assumptions are the population of different scores are normally distributed and there is independence within the groups. A more obvious assumption is that the two samples should be of equal size, as the term related samples implies. Like the one independent samples t-test, it is robust to violations of normality when sample sizes are 30 or more. One potential application of this method is the analysis of a randomized pretest post-test design. And as you can see here, I'll go down here. As you can see here, here is the notation for a randomized pretest post-test design. Another potential application of this method is the analysis of a non-randomized pretest post-test design. In other words, what would be referred to as a quasi-experimental pretest post-test design. The design notation would look something like the following, and here it is. In addition, the two independent sample t-test is used to test hypotheses concerning the difference between two population means. Assumptions are normality. Data in each population being sampled is normally distributed. Random sampling, each of the two samples are collected through some random selection process. Independence, probability of each measurement is independent from other measures. And equal variances, that the variance of each population is equal to each other. The equal variance assumption can be tested through the use of an F-test. SPSS also, also provides a feature to test for the assumption of equal variances. In cases where equal variance cannot be shown between the two groups, there is a form of the two independent sample t-test that can be used to account for this violation. There are various examples of when a two independent samples t-test would be appropriate. One of them is the randomized post-test only design. Interestingly, this relatively simple design is one of the strongest in terms of internal validity. And here you have that randomized post-test only design. Hypothesis testing using t-test represents a way to compare means between two groups when the data being collected is continuous data. Point estimation and confidence interval estimation is an alternative method that allows us to estimate population parameters within identified bounds based on a desired probability level. Hypothesis testing using two independent sample t-tests and the alternative point estimation and interval estimation approach are important to understand. And we go into the objectives for this module. And then there's an overview. Go into an overview of the module. Let's reflect on the fact that t-tests can be used in either experimental or non-experimental situations. In the case of experimental research, we are concerned with making causal claims. The populations being investigated are hypothetical and based on random assignments to groups, with one group receiving one form of a treatment and the other group receiving another or no treatment at all, comparison or control group. In this case, these groups represent hypothetical populations, and equivalence of the groups has been ensured through random assignment to groups. A two-group post-test only design is a very good candidate for the use of the two independent sample t-test when examining causality. And there you have that two-group post-test only design. A non-experimental design can be used to compare and examine real populations to see if they are different from each other. Causality cannot be established, but we can establish if the groups are the same or not. In a non-experimental design, we take a random sample from each real population and then compare these samples. It is through random selection and random assignment that the inferential statistical procedures we are examining allow us to validly infer our findings to that of the population and to help establish external validity. That is, to make claims about populations from our sample data. Ensuring random sampling or random assignments does require work by the researcher to establish a protocol of some form of randomness. Experimental designs are based on random assignment, which ensures randomness and are good candidates for the use of the t-test when comparing two groups. Quasi-experimental designs, a form of a causal research design that does not rely upon random assignment, but rather uses some form of convenience sample or intact group, can also be analyzed with the t-test. Although these types of designs can sometimes require more sophisticated approaches to statistical analysis than the t-test. Thus, sometimes there are trade-offs. A researcher can invest the time into a research design that ensures randomness and then be able to use fairly straightforward methods of analysis such as the t-test, or they can choose to use convenience samples, quasi-experimental designs, which might require more work put into the statistical procedures used. Consider your own research interest. Consider groups that might be investigated and compared. Consider the variable to be measured and reflect on the level of measurement the data must be in order for it to be appropriate for the t-test. In review, there are 4 levels of measurement. They are nominal, ordinal, interval, and scale. Okay, now going into the assignments, the reading assignments, and then assessments for Module 6. From the statistics for the behavioral sciences, review chapters 9, 10, and 11, and then in how to use SPSS, section 6.3, independent samples, t-test, and also look at Appendix A, effect size. The assessments, Module 6, reflective commentary, the link is below, and also a reminder that the research article summary is due on February 15th. And the links are here in Blackboard Learn. And you can start working on assignment 2 and that will be due in an upcoming module, actually in Module 7. There's also a link in this module. Things to think about for the next module. To this point, we have examined statistical methods that can be used to compare two groups. Have you considered what we might do if there were 3 or more groups to compare? In such a situation, we use a procedure known as the analysis of variance, or ANOVA. This is the next topic we will address. If you'd like to move forward, please begin to review Chapter 12 and the one-way between subjects ANOVA. And then just going through the site for Module 6, here's the link, Research Article Summary. Again, this is due February 15th. And then the Module 6 Reflection. And here's the link where you can go in and upload Assignment 2 when you have completed it. As always, if you have any questions, please let me know, and talk to you later.